Dr. Abhay Bhadani, Head Data Science Division and Technical Architect at YASA.com. Dr. Bhadani earned his Ph.D. in Telecom and Decision Sciences from Indian Institute of Technology, Delhi. He carries about 10 years of cumulative experience in different industries, including healthcare, telecom, aviation, and hospitality, and has built and guided several cutting-edge products using NLP, machine learning, and data science skills. Dr. Bhadani will be sharing his thoughts on data science and machine learning application in the agriculture domain. I welcome you, sir.
Yeah, thanks for inviting me. It was really a very good sessions. The vision of Mr. Navneet and was greatly shared. Talk by Rajiv Sharma was just awesome. Right? He covered almost everything that comes under the purview of data science or machine learning or AI or robotics, right? So because these are completely interlinked fields, right? So it becomes very challenging to make any model that works, and then you have to interact with the people who are considered to be least literate, in the sense that they are not very handy towards technology and have a fear of technology, using technology, right? And certainly the model presented related to climate change and the previous talk, right? It was just a very good. Sika presented some optimizations, did some optimization, and mentioned that how basically soil data can be used to basically optimize with the type of crops to do some better yield of the crops, and right. So certainly people are working in different many people are working in different domains, but then when it comes to climate change or agriculture or coming up with a solution which requires collaboration from different parties, right? It really becomes important to talk to different people and collaborate and come up with a solution, because it's really very difficult or challenging to work in isolation and come up something interesting which might be really useful for the society, right? So I'd like to just present my screen. I hope it is visible.
Yes, sir.
All right, great. So all right, so the flow of the talk would be, I'll be primarily discussing about the challenges that agriculture is facing, how AI can help, what kind of sensors, networks can be used, different types of sensors that are available in the market, right? And how machine learning can help in decision making, and basically after understanding the pattern, and then again based on that, it would help the farmers or different stakeholders by sending alerts in a timely manner, so that this action can be taken on the ground, right? What are the current challenges? What is the condition of India, especially if we talk about the land records, right? And how AI can be applied, and what kind of designs. I have tried to come up with a design that is likely to cover most of the things, but certainly, as I said, it's an extensive area. Certainly means it would require multiple modifications and iterations to come up with a stable architecture which can really be helpful for the society. So we all know that agriculture is the primary source of the food, right? So whatever we eat is actually produced somewhere in the world, right? Primarily, India is self-sufficient in terms of agriculture. But then if we talk about the global challenges, so it has certainly increased, but the global production has increased gradually over the time. But then it was mainly because people have started cutting forests or using barren lands and other things. Certainly there was some contributions related to coming up with pesticides, fertilization, different types of machines, right? Even tractors and other simple machines which we normally see have attributed in growing. But then since the population is also growing, it becomes really challenge that how are we basically going to overcome this challenge, or since population is growing continuously, but then you are not able to find space to cultivate in just the traditional way that the farmers are doing at this point of time, right? Means we are all aware that due to climate change, either there is too much thunderstorms or too much flood in one particular area. Other area is completely dried up, right? Which was not the pattern even I would say just 5 or 7 years ago, right? Means I've seen from 2013 to onwards, it has been continuously some or the other areas are getting affected, even a tsunami which occurred a bit earlier. But then these things were not happening earlier, and these have certainly come up, and it has just become a very common thing that you can expect a rain on a summer day, and on rainy seasons you are not getting even a single drop of rain, right? So that now, but then how are we going to deal with these kind of challenges? And let's say if we talk about agriculture, how technology can help primarily in improving the cultivation productivity, and that too ensuring the quality of the product is really good and sellable in the market, considering all nutrients are present, right? So all right, so the demand for the food is likely to increase, right? So hardly 4% of land would be available, and we need to feed 60% of additional population. So if you talk about the housing problem, people have started building floor by floor, right? So high-rise buildings to address the problem related to housing, right? But then how are you going to do the similar thing on the agriculture? Right, you cannot do a layered approach in agriculture. But certainly there are hydroponics that is being used, but then that is a bit costlier, as well as it would require a huge amount of investment. Plus, it's very difficult to scale. Now that is the most important point, right? So we certainly need to rely on technology, and that too. This is, I would say, an ideal time to use artificial intelligence or machine learning, right? Even it was rightly mentioned that you get data from several sources in several formats. So I'm sure if you talk about several formats, it means a piece of news article is a different format than considering data which is available in a tabular format, in a columnar format. Sometimes the data is a mix-up things, so you need to all process them, right? We also need to now do some kind of collaboration with, for example, let's say electronics engineer, right? Or people who are really very good in dealing with sensors and building devices which is resilient to climate and can be easily deployable, right? So these are certain factors that needs to be considered. So AI allows you to understand vast amount of data, and certainly it detects the patterns that is underlying the data, and it can actually come up with some solid prediction or patterns. I'm sure many of you must have been using Amazon, or let's say even Netflix, or different kind of platforms, right? It actually tries to understand what you would like to know. Are you going to purchase, or what kind of music you are going to listen next? And most of the time it is most accurate in that sense, because it has been trained with a huge pattern. Now if we are able to come up with a similar kind of solution using this data, right, then it can certainly be very helpful to the agriculture scientists or the farmers or various kind of stakeholders who can design the policies as well as take different kind of decisions according to that. Now we have to start using different kind of sensors, which, as I said, it needs to be designed in a manner that it can be deployed in the fields. We also need to ensure that these data are continuously sent and is processed on real time. There could be various types of models. For example, let's say if some animal is entering your field, or let's say there is a fire in some place, you can send some kind of alert to the farmer and ask them to take appropriate action, right? And these can easily be done with the help of mobile apps. And certainly this is one of the way to interact with a human, right? Because with the help of 4G, now 5G, and the mobile apps, which is means everybody is now owning at least one smartphone in the country, right? So that can help people to basically interact with the fields directly, even if the person is residing at some other place and may not be monitoring the land on real-time basis, right? So certainly technology can help there. There could be various patterns that can be used. For example, how weather is changing, what kind of weather do you expect in next 1 week, or let's say next 15 days or 30 days, because crop cycle has different life cycles depending on the type of crops that is plowed on the field. So we need to understand these patterns, right? And I'm sure the advances that has happened in the computer vision, right? It can automatically detect the number plates, the numbers that is written on your vehicle. Similarly, unmanned vehicles or the autonomous vehicles that you might be listening in the news about, Tesla, or let's say even Google, unmanned cars that is being trained. And all these things can be done only with the help of computer vision being one of the most important thing, and certainly mechatronics, robotics, and machine learning helps in learning the pattern, when to apply brakes and all those things. Now, similarly, if we are able to come up with in the agriculture sector, for example, identifying what kind of weeds are going, or let's say what kind of pests should we apply, or what kind of disease is spreading in the field. So in that case, we can take appropriate action, design a flight path for a drone, and then it can only spray to a limited area of the field, and then certainly the disease will not spread to the entire field, and may not would able to control at a very localized section. So it provides us a unique opportunity to develop intelligent seeding methods, or for example, precise fertilization, and you can come up with the different kinds of combinations, in which order should we plant so that a maximum productivity can be taken out. And let's say, even if I'm sure many people must have heard about the deep irrigation, right? So it uses very less amount of water to give the same productivity, and is being widely used in Israel, right? But then India is totally dependent on the fresh water that we are having, and which is again decreasing in as we are continuously using fresh water for plantation or agriculture thing, and the groundwater is decreasing its volume. So there could be various kinds of sensors: proximity sensing, remote sensing, right? IoT and image-based precision farming. So just by seeing image, you would be able to tell what kind of insects has come, or whether the fruit has ripe or not, right? What kind of action needs to be taken, and so on. So now, if we talk about different technologies, right? For example, satellites can help you in identifying what is the chlorophyll level in the fields, right? And what kind of fertilizers, herbicides, water may be needed at appropriate time. And if we deploy drones, which can again be controlled through, let's say, mobile app, in that case, it can quickly or accurately, if in an effective manner, it would be able to spray or control the disease, right? And certainly using these technologies has its own advantage. For example, the industrial grade T16 drones covers nearly 25 acres of farmland per hour, whereas a typical farmer on foot can only cover 2 acres, right? Which certainly gives you tremendous advantage if we start using technology. This is just one of the examples. You can also control the spray of pesticides or different kinds of things that would be required at the appropriate time. You can decide on which order should whatever you are planning to spray is basically can be controlled using the drones, and you can define the flight paths. So it's like you can see in the images there are different types of patterns that has been shown here, and based on the situation, you can basically deploy and decide on which order it should run, so that it can effectively, it is very effective in achieving the purpose. Now there are various other factors. What should be the height of the drone, or what should be the this needs to be again decided using different kinds of technology. For example, lidar is one of the technology that can help you define what should be the height. Lidar is primarily used in doing some kind of volumetric analysis of a coal mine, or let's say even for a mountain which might contain different kinds of stones, right? So and certainly it can also be used in the farmlands. So we need to engage with these kind of experts to come up with what would be an ideal use case for in this particular case. Now I'll just cover some kind of sensors that can be used to design these kind of solutions. Soil moisture sensors. There are various types of soil moisture sensors that are available. Volumetric water content, capacitance, TDR, neutron probe. Right? There are different kinds of temperature sensors to measure what is the heat. So thermocouples, resistance temperatures, thermistors, semiconductor-based ICs. So wind speed and direction sensor, this can help in detecting what is the speed of the wind. We can use these spin or direction sensors maybe to help us in basically recharging our devices, maybe through wind or even through temperature sensors, right? And it can also help in deciding maybe from which direction the wind is going to flow and what kind of rain we can expect, and so on. pH sensors, right, to basically identify what kind of nutrient is essential for the growth of the plant, right? GPS sensors will accurately help in positioning where to spray and can help in guiding the drones. Accelerometers and the smart cameras that can be used to detect some kind of intervention by animal, or let's say human, or fire, or any kind of thing, which if we see any kind of anomaly, an alert can be sent almost on real-time basis. So these are some of the sensors that are widely available in the market, and we can certainly use these pieces to come up with an IoT design and which can be deployed on the agricultural land, which continuously monitors the desired feature, whatever is meant for. For example, humidity would measure the humidity, the soil will tell you the quality of soil that is present, right? And various kind of devices that are available. We can use them and then come up with some kind of solutions that is able to send data to your edge server first, and then edge server would be sending you your data to the cloud servers, and then on the cloud servers you can basically train your different kinds of machine learning models, and then again from there you can send to the content distribution network, and then gradually to the app Right? So AI algorithms can draw connections between various observations from data captured from different sources, and that too in a different format, right? So we need to process those data most likely on the cloud, because it is really heavy in compute. So it's always desirable to work on the cloud, especially if we are processing any data or training a model, right? So this can help in, let's say, when drought happens in one particular region, the water quality and quantity is affected. Right? Land subsidence is related to underground aquifers impacted. Certain plant species thrive while others might perish, right? Depending on the situation, right? Specific farming equipment and practices help, and others are destructive. So we need to understand what kind of goal we are going to achieve. It may certainly vary from one type of crop to another, right? So we need to first identify a problem, and then based on that we can design or adopt a particular technology. So certainly if we have the enough data and then we have made different kinds of model, then it would be able to help you in coming up with a solution that would give you certain kind of answers. Maybe should we use pesticides at this particular time, right? Should we plant homo or heterogeneously? Should we pump water, right? Or change the product grown instant? So it depends that continuously, let's say, if a farmer is growing, let's say, only sugarcane, so is it a possibility that next time we don't grow a sugarcane, but let's try out with something else? So that kind of decisions can be governed using these technology, right? And then it would also help in coming up with these answers based on the soil properties and several other features available in that particular region, right? So it can also help you in deciding whether the small farmland is better in long term or a long farmland is better. So these kind of analysis can also be derived, right? Plus other examples could be soil health, food safety, and several other parameters can also be predicted, right? Now, current state of land in India. So India is primarily dependent on agriculture, right? But then one of the most messy thing of India is that currently the land ownership is really in a messy situation, and it is established through there is a complex process, and mostly it is done by different parties, right? So this is poorly managed, maintained. So let's say if we have to come up with some solutions which would be applicable in a large agricultural land, then it would become very difficult for technology which would be able to help, because if you apply these technologies in a smaller piece of land, it may not give you the desired advantage in terms of cost, right? So that can be a messy thing. So certainly government is has done very good effort in modern digitizing the land record. Still it needs to be refined furthermore, and different kind of policies needs to be implemented that would allow people to share land for a collective effort, and ensure that the farmers are not suffered in this process, right? So these is also one of the challenges, right? So now AI has advanced in many fields, but right, we have chatbots, we have email bots, we have unmanned vehicles, but unfortunately we do not have very popular framework, or it is not widely being used in the agriculture field, right? Though everything is available, maybe it's about the collaboration that is missing, or possibly people are working in isolation in their institutes or their research area, but then certainly people are not working in collaboration. So if we have to come up with some solutions, these would certainly be very helpful by collaborating with different experts in this area and work towards achieving this goal of using the technology. It's not about that the technology is not available. It's about using in a collective manner. So another challenge of using AI is initiatives, right? So which we have already discussed. Now, if we talk about the applying AI, it could be classification of insects, crop disease, and its detection at an early stage, right? Alerting stakeholders related to attack by animals or insects or swarms, right? Bringing operational efficiency and uniform distribution of pesticides. So water, herbicides, or fertilizers with the help of drones and dispensers. Now, these dispensers can also be controlled using your app, and based on that, it can dispense the amount, right? Ensuring water and nutrient availability, ability to take real-time decisions with the camera, right? So how to start, right? Start with a problem identification. What we are going to solve, in which kind of cultivation, what would be the agro product that we are targeting. Establish data collection pipeline, because if we do not have data science or AI won't be useful, because it works on the patterns, and to come up with any pattern, you need a huge amount of data that needs to be established to start with. So we need to first establish data collection pipeline, right? And design the architecture depending on where computations should happen, where data should get stored, and how this information should be communicated to the audience. Train the model and again retrain the model, because it should relearn continuously, learn to evolve and bring an accurate so that an accurate model stays relevant, I would say, right? So retraining is very important. And what should be the strategy for retraining the model, right? So we can also come up with voice bots, right? On the app itself, you can ask in your local language, and the machine learning model should be able to tell you in the local language that is available. So it's just like a chatbot or Siri, or let's say even Alexa kind of thing. So these are all possible these days, especially with the advancement in speech technology, natural language processing. I have been working in speech as well as natural language processing for more than 5 years. And now I think it's really time to apply in real life and should be used and applied. So this is the framework that I have tried to come up with. You collect different information from cameras, soil moisture, temperature, pH sensors, wind direction, then send it to a edge server, which would be a very small piece of device, which is just stores data, which is being sent continuously by these sensors. And then it routinely sends to the actual cloud, on the cloud, where your data is getting stored in different formats. Then machine learning models can be trained with the help of these data, which again needs to be cleaned. This is a very abstract model. There are many steps that I'm really skipping in this process. But if you once you have cleaned the data, you start predicting, and then based on that, you are able to you can have multiple models lying here, right? And these models would have different tasks, which will get distributed to a content distribution network, right? Similarly, a different kind of information can be captured. For example, this would be related to field data, and whereas this data would be some external data. For example, the data coming from your satellite, or let's say past temperature, past rain pattern, and all these kind of data can be coming from here, from a different model. And again, this can alert you from early warning or alerts related to thunderstorm, wind, or any other disaster that is going to happen in advance. These models, which are controlled directly by the data that is being collected, can help you in what kind of insect has come to your fields, what would be the ideal time to spray, when the fruit or the crop has ripe, or and different again alerts related to animals, human, fire. These things can be sent to the content distribution network. And then from here, you are basically connecting with the app, and your app is getting powered, which can be used by a person, right? And then from the app, you can also talk, and with this kind of framework, you can also give your feedback, or you can talk maybe using voice-based or chat-based system, or you can simply consume the information which is being sent in the form of alerts. You can also control the drones, and then decide what would be your flight pattern of the drone, and then you can spray your fields cover. Now again, some kind of suggestions can be given from here, that your pattern should be just focusing on one corner of the field rather than spraying on the entire field. These kind of decisions can certainly be very helpful for farmer, and it can certainly help to achieve agriculture production at a higher rate, as well as it can give a very good price, because the quality is controlled not just by one person, but by a collective data which is being basically learned with the pattern using the ML or AI. So that's all. So I think I'm on time. So AI can help in crop yield production, intelligent spraying, controlling drones, crop soil monitoring, disease diagnosis, inform stakeholders, early warning systems, and there could be even more areas. So thank you.